Okay, so in statistics, when we ever say the word and, we're always talking about multiplying things. So the word and is not necessarily always shown in the question, but when you read it and you ask yourself in your head, what do you want? If you want one thing and another thing, then you're going to multiply them together. So if we look at some examples for and, the first one says, James and Sarah are both taking a music exam independently. The probability that James passes is 3/4, and the probability that Sarah passes is 5/6. And what's the probability that they both pass? So that question, nowhere there does it mention and in our question that it's asking, but they want that both pass, which means that James is going to pass and Sarah is going to pass. So the probability that both will pass is going to be the probability that James passes, and, so I multiply, the probability that Sarah passes. The probability that James passes is 3/4, and the probability that Sarah passes is 5/6. So 3/4 times 5/6 gives you an answer of 5/8. Whenever the question gives you fractions, you give the answer in fractions. Whenever the question talks about decimals, you give the answer in decimals. Okay, so now the next part says, what's the probability that neither of them passes? Again, there's no and in that, but by saying neither passes, that means James is not going to pass and Sarah is not going to pass. So our probability for neither of them is going to be the probability that James doesn't pass. Whenever we put a little symbol like that, that means the opposite of it. So if this is James passing, that means James is not passing. And Sarah is not passing. So the probability of James not passing is going to be 1/4, because remember the probability has to equal a total of 1. And Sarah not passing is going to be 1/6. So if we put that in our calculators, we should get an answer of 1/24. Okay, so then if we look at the next question, I have got Simone and John playing darts. The probability that Simone throws a bullseye is 0.1. The probability that John throws a bullseye is 0.2. Simone and John throw one dart each, and the winner is the person who throws the bullseye. If they both throw a bullseye, the game is declared a draw. Now we need to find the probability that the game is declared a draw. So if it's a draw, it means they both throwed a bullseye. So that means Simone throwed one and John throwed one. So the probability of having a draw is going to be the probability that Simone throwed a bullseye, and, so we multiply, the probability that John throwed the bullseye. So the probability that Simone got one is 0.1, and the probability that John got one is 0.2. So if you type that into your calculator, you get an answer of 0.02. So as I said before, because this is now in decimals, we give our answer in decimals. The probability that Simone wins. So that means Simone threw a bullseye, but only she threw a bullseye. So that means that she threw a bullseye and John didn't. So our probability that Simone wins is going to equal the probability that she got a bullseye and the probability that John didn't. So her probability of getting a bullseye is 0.1, and his probability of not getting one would be 0.8. because 0.8 plus 0.2 adds up to 1. So 0.1 times 0.8 gives us an overall answer of 0.08. And then our last part of that question is the probability that John wins. So if John is going to win, that means we want the probability that he got a bullseye and that she didn't. So that's the probability of John getting his bullseye and the probability that Simone does not. So John getting his bullseye is 0.2 times Simone not getting her bullseye, it would be 0.9. So 0.2 times 0.9 is 0.18 for our overall answer. Okay, if we look at the next question, I have got a standard cubical die thrown twice, and I need to calculate the probability of getting 2 even numbers thrown. So I want to throw them 2 times, and it doesn't tell me which even numbers, it just says that I need to calculate the probability that I get 2 even numbers. So that means I get an even number on the first throw and an even number on the second throw. So my probability of getting 2 even numbers would be the probability of getting an even first and the probability of getting an even second. So the probability of getting an even number on a cubical die, because there's 3 sides that are even, would be 3 over 6 sides in total, times, throwing the dice again, there's still 3 sides, over 6 in total, so that gives us an overall answer of 1 over 4, and that's it. And then if we look at our next one, we have Kirsty and Justin both preparing to take a driver's test. They each learn to drive separately, so the results are independent, and the probability that Kirsty passes is 0.6 and the probability that Justin passes is 0.4. So we need to find the probability that both pass their test. So if they both pass the test, that means it's going to be Kirsty passing and Justin passing. So my probability of both is going to equal the probability of Kirsty and the probability of Justin. So the probability that Kirsty passes is 0.6 and the probability that Justin passes is 0.4. So 0.6 times 0.4 gives me an answer of 0.24. Then the probability that neither of them passes means that Kirsty won't pass and Justin won't pass. So my probability for neither will be the probability of Kirsty not getting it and the probability of Justin not getting it. So Kirsty not passing would be 0.4 because 0.6 is that she does pass, and Justin not passing would be 0.6. So 0.4 times 0.6 is 0.24. Okay, and then our last one, Kirsty passes the test and Justin doesn't pass. So if Kirsty passes and Justin doesn't pass, I want the probability of just having Kirsty, which means that she is going to pass and Justin is not going to pass. So for Kirsty passing, her probability is 0.6, and for Justin not passing, the probability is 0.6. So 0.6 and 0.6 equals 0.36. Okay.